Well, thank you very much. As I said, my name is Sebastiaan, and I'm actually very happy to be here today. I was a little bit worried with the recent numbers going up, but the reason that I'm very excited to be here is because I don't live here in Groningen, but my father was actually born very close to here in Groningen, and my family used to live here for generations upon generations. And recently I came upon a photo of my great-great-great-great-great-grandfather, give or take a great in there, that was taken close to here. He lived in, why don't you work? Right, here it is. He lived in Eenrum, which is to the north of here, and here he is on the bike. He used for races in this area. He used to win races, and just look at him. He's very cool. That's proper old school cool. I already know that I'll never be as cool as my great-great-great-great-great-grandfather. So, yeah, I just wanted to share that with you. But who am I? Maybe that's more relevant to you all. My name is Sebastiaan. I'm 35 years old. I used to work in academics. I used to do things with teaching statistics to psychology students, which is a very nice job. You get a lot of reward from that. I also did a little bit with research into evolutionary algorithms and stuff like that, which was a lot of fun. But it didn't really make me happy, so I decided to change my career, move into software development, and Python has been a hobby of mine for a lot of years. So that's what I ended up doing, and since the start of the year, I work for Ordina, for the Ordina Pythoneers, which I like a lot because we have quite a few Python developers in our unit, and it's always great to be able to talk and work with other Python developers. It's really great to be able to exchange ideas within your own peer group, so to say. I'm also involved in Python Discord. I'm one of the people who try to make it a good place. It takes a lot of time and effort. We've been building it for a couple of years now. And currently we have about 100 people who are actively involved in the organization, organizing events and stuff like that. So that's really a great thing. And one of my recent highlights is that we organized the Python 3.10 release stream with some of the core developers, which was a lot of fun. And I'm also a volunteer for EuroPython, which is another conference that you should all visit next year in Dublin. Right, so the magic of self. I'd like to start with a quote by Guido van Rossum. And he says that from day one, there was deep magic hiding in some places, designed to quietly help users. And in a lot of ways, this is true. What Python does, it gives you a very high-level interface. It gives you a lot of abstractions to work with that allows you to focus on your business logic. This is a lot of fun. It makes it really easy to write code, but it also makes the statement true that Python is very easy to learn, very easy to get into because you can focus on the business logic, but it's quite difficult to master because once you dip your toes beneath that surface, you find a lot of complexity, a lot of magic methods. In the data model, we've seen in the previous talk, we've already seen a lot of magic methods and ways to inspect your functions during runtime. There's a lot of complexity that comes into play, a lot of magic that you can start to play with. And today, what I hope to do is by going into one of the most magical things of Python, at least for me when I was learning Python, self, I hope to show you that most of that magic is there for you to use, that you can actually use that magic yourself. It's not just something Python does for you. There are some pieces of magic that you cannot replicate, but there are a lot of magical things in Python that you can actually use yourself to write better software. And that's what we're going to look at. But first, what is the magic of self? The example that I'm going to show you is probably really easy for you all. And that's on purpose because I want to start from a common footing, from the same ground. And what I'm going to do is I'm going to write a very simple class, a guitar class, which you can see here. And I wrote this as part of a little system I wrote a couple of years ago to practice with classes to take a stock of my guitar collection. I've got quite a few guitars. I like a lot of them. My girlfriend always says I have too many. I should get rid of a few because they take up a lot of place. Here I'm writing a simple class, and this shouldn't surprise you. Now you can create a guitar instance. This is my bass guitar, my Warwick Streamer. And I can pass in the name, and it will create a guitar instance for me. And then when I access the name attribute, you get the name out again. Well, this is not really exciting, so let's add one more thing, which is a play note method, which you can see over there. This is a very simple method. It's really difficult to make my guitar play with Python, so this is like a mock guitar, and it will just, you can pass a note to the method, and then it will just print the string myself.name, whatever guitar that is, place the note, and then it will print the note. Well, it's not really exciting, so I can call it, for instance, with C#, which to me is a musical note, not a programming language, and then it will print my Warwick Streamer, place the note C#. Pretty straightforward. But if you zoom in on this method definition here, or actually this function definition here, there is something interesting going on. Because if you look closely, you can see, if you define this function, you actually have two parameters here. You have the parameter self, and you have the parameter note. And this is important because when you look at how we call that method, we only pass in one argument. And that argument obviously ends up with the parameter note, but where's the value for self coming from? Well, and when you're teaching beginners, you typically say something like, well, Python just takes care of it for you. A lot of intermediate Python programmers or advanced beginners, they just get so used to this happening that they don't really look into it anymore. But what will happen is that Python will insert the current instance that you call this method on, it will insert it as the value for self. This is not just a magical thing that you cannot replicate, but there's actually a well-defined protocol behind it, and that's called the descriptor protocol. So what I'm going to do for you today, we're going to look into that descriptor protocol, we're going to see how this works, we're going to replicate the functionality ourselves, and then hopefully you get an idea of how this works, and hopefully it will give you the confidence to dive into more of these areas of Python, to hopefully learn more about how the language works. So, methods in Python, what are they? Well, first, let's take a look at my class definition again. When you define a class in Python, you're actually defining an object again. Everything in Python is an object, including classes. There are instances of the class type. So if you represent that class object here by this rectangle, you're actually defining an object with methods and attributes when you're entering this class definition. Now let's zoom in on what happens when you define this function. So when you define the function play note, what Python will do for you, it will create a function object in memory. The people who were here with the previous talk, you have a little bit more info on that now. But basically this will be another object. This truly is a first-class object in Python. It will have attributes, it will have methods. This is an object that you can work with in memory. But we don't really have use for objects that don't have names assigned to them. So when Python runs such a definition statement, it will also bind a name to that object. And because we're in the context of a class, this name, in this case, it will be a class attribute, play note, and that class attribute will be assigned to the function object. And what is important to realize here is that that function object is still mostly a regular function object. There's nothing really magical about defining a function in a class. So this in itself doesn't explain self yet. This is just a function object. The fact that it's placed within a class is important, but you could also define your function outside of your class and then monkey patch it on your class or add it to your class in your function definition, and Python will still insert self. So that this function definition statement was placed within a class body, that doesn't really matter. But what does matter is that we've bound a class attribute to the function object. And to understand why, we need to look at what happens when we access functions or methods in Python. All right, accessing methods in Python. So here we have our class again, and now we can see if we access that class attribute directly on the class, then what we'll see is that we just get the function back. This already shows that deep at the heart, there's still just a function that Python has. There's something funny going on here with the wrapper. You can look that up on YouTube if you like. But anyway, if you access your method like this, you'll just get the function back. But what we can also do in Python, this may look a little bit weird, we can create an instance of the class and then access that method as an attribute of that instance. Now, if you think about that, that's a little bit weird. The instance doesn't even have a plain old attribute. The only attribute that I've added to it myself is the .name attribute. It will have some default attributes as well. But this instance, it doesn't have a plain old attribute. So how can we access the plain old attribute on the instance? Well, that's because of how attributes in Python work. If you look up an attribute on an instance, Python will first look at the instance. Does this instance have that attribute? If not, it will move on to the class. It will look at the class. Does this class have this attribute? And in fact, here we know that the class does. It does have a plain old attribute, so we can access that attribute that way. But if we look at what happens, then we can see that we get something different back. Instead of the function, we suddenly have a bound method. And this really is that magic of self. When you access that function using the instance, you get something else back than when you access it on the class directly. So how does this work? Well, the story I just told you about first looking at the instance and then looking at the class, that's an oversimplification. Objects can actually modify what happens when you look up attributes. And those kind of objects, those are called descriptors. And that's what we're going to look at next. What are those descriptors? And then we're going to understand how this works. Well, descriptors are objects that implement the descriptor protocol. And those objects, they can modify the lookup of an attribute, the assignment to an attribute, or the deletion of an attribute. They can do that by implementing three special dunder methods. Dunder get, which influences the attribute lookup. So like we just did when we access playnode on the Warwick instance. You have a set method, which changes what happens when you assign something to an attribute. Then you can manipulate that. You have the delete method, and it will come into play when you use a del statement with an attribute. So these three methods allow you to customize what happens when you access an attribute. And functions are such descriptors. They only implement the get method. They don't implement everything. But that is how functions will insert self. They will manipulate what happens when you access them using an attribute on the instance. So, what does that look like? Well, for that, we're going to implement a very simple descriptor. And then we're going to look what happens. So this is a class again. I'm just going to collapse all the other methods to create some room. And what I want to do is I want to create a new class attribute called isMyFavorite, which has a special object which it binds to, which is my favorite descriptor. And the idea of it is that it will indicate whether or not this specific guitar instance is my favorite guitar, represents my favorite guitar. And my favorite guitar at the moment is my Warwick Streamer bass guitar. It's not really my favorite, but I just play on it the most. So what I want to happen is when I access warwick.isMyFavorite, then it should print true. If I create an instance for one of my other guitars, say my Fender Jazz Bass, which is also an excellent guitar, by the way, if I then access that attribute, it should print false. And this is really what we want to do. So how can we do that? Well, let's implement the favorite descriptor. Well, it's a class because it has to implement methods. So we're just going to start with the class favorite descriptor, and then we're going to add one method, and that is that dunder get method. Now, if you look at the signature over here, you can see it takes three parameters. It has that self, which is referring to the current descriptor instance. Then it has the instance. This will be the instance you access the attribute on, and it will have the owner, which is the class of the instance. And what we're going to return is a Boolean, either true if it's my favorite guitar, or false if it's not my favorite guitar. And in some situations, which we'll get to later, it will also return the descriptor instance itself. And if you notice here, this is the neat thing in Python 3.10 to specify unions. You don't have to import it anymore from typing. Right. The first thing that we need to take into account is that my descriptor is assigned to a class attribute. It's assigned to this thing over here. So what happens if we access this as a class attribute? Well, what Python will do, it will insert none for the instance. So we can check for that, and that's what we're going to do. If your instance is none, then we know that there is no instance. We've accessed it as a class attribute. And a very good thing to do, if you don't have anything else special to do, is just to return the descriptor instance itself. This makes it very easy to introspect the descriptor. Now, once we're past this if statement, we know that we're dealing with an instance. They're going to implement a very simple return statement, namely, if the instance.name is equal to Warwick Streamer, then we will return true and we'll return false otherwise. Obviously, this is very naive code. It assumes that the instance has a name attribute, that we can compare it to a string. But this is just an example. We're not going to deal with that. And if we do this, and if we define the class as above, then it will simply work. Now I can create an instance. I can access the attribute. What will happen is that Warwick will get passed as the instance. The class of Warwick, so guitar, will be the owner. So instance is not none. We will make it past it. Warwick.name is equal to Warwick Streamer, so we will get true. Well, the same goes for my Fender. If I access Fender, that is my favorite, then we'll get false because the name of Fender is not equal to Warwick Streamer. Finally, just to demonstrate what happens if you access this as a class attribute, well, since if you access this as a class attribute, instance will be none, so we will just return the descriptor itself. And this is basically how a get method, a descriptor get method works. Okay, so move on. What we're now going to look at is how functions implement such a get method. And basically, how functions implement it is in the very same way as we've just seen. So this is a functions get method. It's actually defined in C, so this is pseudocode in Python. But basically, all functions have such a get method. Oh, that's the wrong button. It will get the instance that you've accessed the function on. It will get the owner class. If the instance is none, it will just return the function itself. And otherwise, it will create something called a pique method, which is the bound method that we're dealing with. And the bound method will get the function and the instance. So it can act kind of like a partial function. It already knows the instance. It already knows to insert it as the first positional argument. And we can see that in action. So if we access guitar.playNote, then guitar is the owner class. We access it as a class attribute. Instance is none. So we should just get the function back. And indeed, we do. We just get the function back again. And basically what happened under the hood is that if you access the function, this is a little bit cheating, and you call the get method directly with none and guitar, you do indeed get that function back. If we now do this for an instance, like my Warwick guitar, now we do have an instance. Warwick will be passed as the instance, so we will make it passed here, so we should see a bound method, and indeed we do. And this is because this is equivalent to accessing the function, calling the get method, and inserting Warwick and guitar yourself. And this is, in a nutshell, the magic of self. Functions are descriptors. They have a get method, and they use that to insert self when you access the function on an instance. Now, mind you, the function has to be bound to a class attribute for this to work. If you assign a function to an instance attribute directly, this won't work. Oh, I didn't show you the output, but I hope it was clear. Now, functions aren't the only descriptors you'll find built into Python. There are a few other very famous ones. You've probably all used them. For instance, you have the class method descriptor. We typically use it as a decorator, and what this does, it will wrap the function object inside of a class method object. And that class method object will have an alternative implementation of the get method that instead of inserting the instance, it will always insert the class. We also have the static method descriptor. You can also use that one as a decorator. It also has an alternative get method. And in this case, it will just not bind anything to it. It will always just return the function as is. And finally, this one is a little bit more complicated. The property, this is also a descriptor. And this one allows you to create getters, setters, and deleters very easily. As you can see here, I've used property as a decorator on the price method, and this will turn price into a property, something that you can access at an attribute. You can also insert a setter here really easily now. So the property is also a descriptor. It also allows you to create getters, setters, and deleters by using that descriptor protocol. Let me check the time. Oh, that's okay. There are also a lot of other famous descriptors out there. If you, for instance, look at ORM, Object Relational Mapper, frameworks like SQL Alchemy or Django's ORM, they will typically use descriptors to abstract away a lot of the business logic that you need to perform, for instance, to fetch things from the database. For you, the end user, you can create a very nice high-level interface. You can just access the attribute, and underneath, the descriptor will take care of lazily loading in all the data from the database. In SQL Alchemy, it will check if your data is potentially stale, so that it has to refetch the data for you. So that also uses descriptors to do a lot of work. Well, then we get to the summary. Well, the top part here isn't really all that exciting. Descriptors allow you to customize how attributes work, which was basically the point of this talk. And functions use descriptors to, functions are descriptors. They implement the descriptor protocol to insert self. What is also important are the things that I haven't covered in this talk. What I haven't really talked about are the set and the delete descriptor methods. And these are really important because there's a little bit of a twist in how that attribute lookup sequence works when those methods get involved. And then you get to something called data and non-data descriptors. In Fluent Python, which is an excellent book, they call it overriding and non-overriding descriptors. But anyway, that's a little bit complicated to explain in a short amount of time. So I recommend you to either read Fluent Python, or Raymond Hettinger also wrote a very excellent tutorial in the, which is part of the documentation of Python, which explains the difference here as well. So if you want to know, just read those. And I also haven't mentioned setName yet. And setName isn't formally part of the descriptor protocol, but it's a method that's used a lot with descriptors. And it's also something worth checking out. You can do a lot of cool things with that. Well, to wrap it up, I'd like to end with a quote. This is a quote from Lee Siegel, who is a magician. He's unfortunately no longer with us. But the quote is, basically from one of his books, I'm writing a book of magic, I explain. And I'm asked, real magic? And by real magic, people mean miracles, thaumaturgical acts, and supernatural powers. No, I answer. Conjuring tricks, not real magic. Real magic, in other words, refers to the kind of magic that is not real, while the magic that is real, the magic that can actually be done, is not real magic. In Python, there's a lot of magic. Some people don't like that, but I say this magic is real. We can all use it. There's a magician in all of you. Go take that magic, dive into that magic, and use it to create better interfaces. Use it to create high-level interfaces for your end users, to abstract away your business logic, to create objects that behave like Python's built-in objects so that people know what to expect. So dive into that magic. Okay, and that's it. If you want to know more about me, you can follow me. If you want to have the slides to this presentation, they're on my website here. It's a very simple website, but there's a link at the top that will bring you to both a handout version and the full PowerPoint version. And that's it. Thank you very much.
Thanks, Sebastiaan. Any questions from the audience? Over there, yeah.
Yes, I have a question about the descriptor get. When you don't have an instance, you return the descriptor instance itself. But why is that?
So the question is, if you don't have an instance, so you access the descriptor on the class, why do I return the descriptor itself? Well, mostly here because I don't have anything else useful to return. So I might as well return the descriptor itself, which makes it easier for people to introspect the descriptor. If there is something else to return, if you want to do something special there, like, for instance, a static method descriptor, then you should totally just return whatever you need to return. So that's basically the only reason why I do it here. And for functions, obviously, there is no instance, so why not just return the function as is, so that you can work with it.
How does the function dunder get relate to the function dunder get adder?
That's the question is, how does the dunder get method relate to the get adder method? This is an interesting one. The dunder get method manipulates these kind of attribute access, so the descriptor protocol. The get adder method is when you access an attribute on the object itself that doesn't exist. Then the get adder method gets called, and then you can do something based on the name of the attribute. So you can make dynamic attributes that are not predefined. So it's basically kind of a different thing. Here you're accessing the descriptor on another class, and get adder gets into play when you access an attribute on the object implementing it itself. I hope that answers your question. It's a little bit difficult, otherwise we can talk about it after the talk.
Just sanity checking. In the get adder, you could return a descriptor, right?
That's an interesting question. I think get adder only gets called on the instance. So if you then return a descriptor, you probably won't invoke the descriptor protocol anymore. I think, but I haven't checked. It's always difficult to make up your mind when you're put on the spot. It's mm-hmm. So the question is, I showed a method earlier, and I can go back to it. There it is. This one is a little bit naive. And what I meant by that is that this descriptor, in principle, has nothing specific to do with the guitar class. So I'm just assuming that a name attribute is present on the instance, and that whatever return value I get back here is comparable to a string. Otherwise it will fail. What you could do is you could access the attribute in a more fail-safe way, or check whether it's there. And if not, you could return false or do anything with it what you want, maybe raise an exception because the descriptor is used on something that doesn't support it. But you could access the attribute and compare it in a more safe way, basically. Well, this is just how the protocol works. You get the instance and the owner class, which get passed, so you need to have a parameter for that. If you read the docs carefully, then it says that for some implementations, owner may not be passed, but CPython always will. So you need to have a parameter for something that Python will pass to your function. You need to have something to receive it. So even if you don't use it, you still need to have a parameter for it. Otherwise, you'd get a type error. Yes, but you don't always have an instance. Sometimes you only you access it as a class attribute. Maybe sometimes maybe you can manipulate the instance to fake its owner. I don't know. There's probably some meta programming in there that could confuse it.
Any other questions? No? Then let's thank the speaker again.